So what happens when you try to do math with a number that's, well, imaginary? It sounds like it should be totally impossible, right? But it's actually built on a few really simple rules. Let's break down how to do arithmetic with complex numbers.
Right? That's the big question, isn't it? How do you actually use a number with that mysterious I, the so-called imaginary part? It feels like adding or subtracting them should just break all the normal rules of math we know.
Well, the secret is to stop thinking of it as one weird, confusing number and start treating it like a two-part puzzle. See, every complex number has a real part and an imaginary part, and the trick is to just handle them separately. That's it. Okay, so let's dive right in with addition and subtraction. And here's the great news. Both of these operations follow the exact same core principle. Seriously, once you get one, you automatically get the other. And you're gonna love this because the logic is super simple. For addition, you just add the real parts together and then you add the imaginary parts together. Subtraction, same exact idea. Subtract the real parts, then subtract the imaginary parts. It's basically just like combining like terms in algebra. You've done this before. All right, let's actually see this in action. Say we have 7 plus 3i plus 5 minus 2i. First, we just grab the real parts, that's the 7 and the 5, and add them up. That gives us 12. Then we take the imaginary parts, 3i and negative 2i, and add those. We get a single I. Now just put the two puzzle pieces back together and boom, you've got your answer, 12 plus I.
All right, ready for subtraction? Let's try 8 minus 5i minus 3 plus 2i. The process is pretty much the same, but there is one classic little trap you gotta watch out for. You have to remember to distribute that negative sign to both parts of the second number.
So, first things first, we apply that negative, which turns our problem into 8 minus 5i minus 3 minus 2i. See, now it's easy. We group the real parts. 8 minus 3 is 5. Then we group the imaginary parts. Negative 5i minus 2i gives us negative 7i. And there it is, our final answer, 5 minus 7i. Same principle, just a little twist. Okay, you've totally got addition and subtraction down. So, let's level up. Multiplication is where things get really interesting. It actually follows a process you already know, but with one single secret rule that changes the entire game. And here it is. This is the golden rule of multiplying complex numbers. Whenever you see I squared, you just replace it with the real number, -1. That's it. This one little substitution is the key that unlocks the whole thing. It's that powerful. So really, multiplying these things is just a two-step dance. First, use the distributive property, you probably know it as FOIL, to multiply everything out, just like you would with variables. Then you do the magic step. Find any I squareds that pop up and swap them for a -1. Let's walk through one together, step by step. We've got 2 plus 3i times 4 minus I. First, we distribute. That gives us 8 minus 2i plus 12i and minus 3i squared. Ah, and there it is. That's the key moment. We see that I squared, so we substitute it with -1. That turns our -3i squared into a +3. Now, we just combine our like terms. 8 plus 3 is 11, and -2i plus 12i is 10i. So our final answer is 11 plus 10i. Okay, you've seen the rules for adding, subtracting, and multiplying. Now the best way to really make this stuff stick is to practice. Let's run through a few quick problems to lock it in. First up, a little addition. What's 6 minus 2i plus 4 plus 7i? Go ahead and think about it for a second. Remember, real parts with real parts, imaginary with imaginary. And the answer is 10 plus 5i. That's just 6 plus 4 for the real part, and -2i plus 7i for the imaginary part. Easy enough, right? All right, next up, subtraction. 9 plus 3i minus 5 minus 4i. Don't forget to watch those signs when you distribute that negative. And the answer you should have gotten is 4 plus 7i. You get that from 9 minus 5 for the real part, which is 4, and for the imaginary part, it's 3i minus a times -4i, which is really 3i times plus 4i. That gives us the 7i. Okay, and for the final boss, the final challenge, multiplication. What do you get for 1 plus 2i times 3 minus I? Take your time, distribute everything, and don't forget that secret rule. Did you get it? The answer is 5 plus 5i. That tricky negative 2i squared term becomes a positive 2. When you combine that with the 3 you get from multiplying the first terms, you end up with 5 for your real part. Awesome job. Seriously. So to wrap things up, let's just boil everything we've talked about down into a super simple guide you can use anytime you're working with these numbers. Yeah, this table right here, this is basically your cheat sheet. For addition and subtraction, all you're doing is combining like terms. The only special thing to remember is to distribute the negative for subtraction. And for multiplication, it's the distributive property, and the most important rule of all, I squared equals -1. So let's just run through the big rules one last time, okay? Always keep your real and imaginary parts in their own lanes. Use the good old distributive property for multiplication, and most importantly, I can't say it enough, always substitute -1 for I squared. If you follow these rules, you'll always get to the right answer in that clean A plus BI format. And you know what? That's really the main thing to take away from all this. A topic that sounds incredibly abstract and, well, complex is actually built on a few very simple, very logical rules. Once you know them, all that complexity just kind of melts away. So I'm going to leave you with a final thought. This isn't just some abstract math puzzle. This stuff is the foundation for things like electrical engineering, signal processing, and even quantum physics. Now that you know the rules of the game, what kind of real-world problems can you imagine solving with them?